Hey everyone, we're going to talk about how to solve a system of equations using the first of three methods, the graphing method. By the end of this lesson, you should be able to graph a system of equations and identify the solution of a system of equations given its graph. A system of linear equations is a set of two or more linear equations in a group. A solution of a system of linear equations is the ordered pair x comma y that makes both equations true. Remember when we studied systems of inequalities, we had a solution set, an entire region where there were multiple points. Well, in a system, we don't have that shaded region anymore. Only those boundary lines are part of that system. So the solution is only going to be one point, no points, or all of the points on the line. The points of intersection are the same thing as the solutions of a system. Okay? It's where the two lines cross on a graph. No solution means that there is no point that makes both equations true. So the lines never cross. What kind of lines never cross? A system of equations has infinitely many solutions when every point makes the equation true. So the lines are right on top of each other. So we just mentioned the three different types of solutions to a system of linear equations. The first type of solution is when the lines intersect. When the lines intersect, there is only one solution. The solution to this system in this first graph here is the ordered pair 2, 1. This is the point where the two lines cross. If two lines intersect, they have different slopes. Here are the example equations. Notice how the numbers in front of x are different. If two lines have the same slope but different y-intercepts, then the lines are parallel. Since they are parallel, they will never intersect, meaning that there are no solutions to the system. There is no point where these two lines will cross, so there's no x or y that will make both equations true. When two lines have the same slope and the same y-intercept, when they are graphed, they will lie right on top of each other. The lines are equal, so there are infinitely many solutions. That means that any ordered pair that works for the first equation will also work for the second equation. We're going to start graphing our systems, but before we do that, let's review. Equations of lines are generally written in two different forms: slope-intercept form, y equals mx plus b, and standard form, ax plus by equals c. When your line is in slope-intercept form, the coefficient of x represents the slope, and the number that's by itself is the y-intercept. When you go to make your graph, you always start at the y-intercept and then use the slope to find different points on the line. If the slope is positive, we move up. If the slope is negative, we move down, and we always move to the right. When your equation is in standard form, use the x and y-intercept to graph. Here is our first system of equations that we are going to graph. The first line, y equals 3x plus 2, has a slope of 3 and a y-intercept of 2. So when we go to graph our line, we're going to start at 2 on the y-axis, and we're going to move up 3 spaces and right 1 space. Since we can't move up and right anymore, we can get a third point on the line by moving down 3 spaces and left 1 space. Once you have at least 3 points, go ahead and connect them. Remember that when you're connecting your points, you use a ruler. Your line goes all the way through the graph, and you put arrows on both ends. Our second line, y equals 3x minus 2, also has a slope of 3 over 1 and a y-intercept of negative 2. This line's going to start at negative 2, but we're still going to move up 3 spaces and right 1 space. Up 3 spaces, right 1 space. Once you have at least 3 points, you can connect them. Line is straight all the way through the graph, arrows on both ends. As you can see, the lines are parallel. They will never cross, so this system has no solutions. Look at the two equations in the second system. They are exactly the same. They have the same slope and the same y-intercept, which means that they are both going to start at positive 3, and both lines have a negative slope of 3 over 4. So we move down 3 spaces and right 4 spaces to get to the next point on the line. We can also move up 3 spaces and left 4 spaces and work backwards to get our third point. And connect the dots. If I make my second line I start at 3 and I move down 3, right 4, it's going to lie right on top of the first line. This system has infinitely many solutions because every point on the first line is also on the second line. In our next example, both equations are in slope-intercept form. Notice how in the first equation there is no number in front of the x. Remember that the invisible number in front of x is 1, which means that our slope is 1 over 1 and our y-intercept is 2. So I'm going to start at 2, and I'm going to move up 1, right 1, up 1, right 1, up 1, right 1, and then connect the points. Again, line all the way through the graph, straight, with arrows on both ends. My second line has a slope of 2 and a y-intercept of 1, which means that I'm going to start at 1, and I'm going to move up 2 spaces, right 1 space. Hey, I landed on the first line. It's probably our point of intersection. Let's keep graphing our line though. Up 2 spaces, Write one space. Connect your points. The two lines intersect. Right where I said, at the point 1, 3, which means that our solution is written as an ordered pair, 1, 3. Remember, all sets of ordered pairs have parentheses around them. Let's check to see if our solution works for both equations. In the ordered pair, the 1 is x and the 3 is y. Is 3 equal to 1 plus 2? Yes. So it works for the first equation. Does it work for the second one? Is 3 equal to 2 times 1 plus 1? 2 times 1 is 2. 2 plus 1 is 3. It works for both, so the solution is correct. Okay, so right next to example 1 on your note sheet is the try it. It looks just like that first example. Pause the video and give it a shot. Did you do it? All right, let's move on. In example number 2, we've got those special type of equations. We're going to graph the line x equals 2. So find 2 on your x-axis. And graph the line of all of the points where x equals 2. This is a vertical line through the point 2 on the x-axis. Now we're going to graph the line y equals -6. Find -6 on your y-axis and draw a line horizontal through that point all the way across. The solution is here. These special cases are the easiest ones to find the solution for because the x-coordinate, or whatever x equals, and the y-coordinate is whatever y equals. So there's the solution. Pause the video and give the try it right next to example number 2 on your notes a shot. Did you do it? On to example 3. In example number 3, the equations don't look like they are in slope-intercept form. And technically they're not. But y is alone on one side, which means that for the first equation, the number in front of x is still the slope, and the number that's by itself is still the y-intercept. So in example number 3, in our first equation, we're going to start at -6 on the y-axis, and we're going to move up 2 spaces and right 1 space to get to our next points on the line. Graph a couple points. And connect the dots. In the second equation, our y-intercept is going to be -6 because that's the number that's by itself.